So today we will discuss about how to find the force voltage and force current electrical and lower circuits of the given mechanical system. So as in the figure, the given mechanical system has two masses M1 and M2. You can see two masses here, M1 and M2. Now a force F of t is applied to mass M1, and with respect to this force, F of t, there is a displacement x1 with respect to mass m1 and a velocity v1, and displacement x2 and velocity v2 with respect to mass m2. So as you can see, a spring K1 and a damper B12 is connected in between M1 and M2, masses M1 and M2. Also there is a spring K2 and damper B2 that is connected only to M2. So here you can see an arrow here. That means that there is a damper that is present here. That is associated with M1. Only associated with M1 there is a damper here, and that is not shown in the figure, but that is represented by an arrow. So that means the mechanical elements in this system are two masses M1 and M2, a spring K1 and a damper B12 that is connected in between M1 and M2, a spring K2 and a damper B2 that is connected only that is only associated with mass M2. Also there is a damper B1 that is only associated with mass M1. So you can see an external force F of t that is applied to the mass M1. So the first step is we have to write the dynamical equations governing this mechanical system. So how can we write these dynamical equations? We can write the dynamical equation by drawing the free body diagram. So first I will draw the free body diagram with respect to mass M1. So free body diagram with respect to mass M1. So this is mass M1. You can see a force, an external force F of t that is applied here. And what are the opposing forces? The opposing forces are force due to mass M1, that is Fm1. Now the next force is, what is the next force? Force due to damper B1. Damper B1 is only associated with mass M1. So force due to damper B1. Now what are the other elements connected to M1? That is spring K1 and B12. So we can write the equation as spring K1, that is Fk1, and damper B12, that is Fb12. Now if I write the force balance equation, here you can see F of t, that is the applied force, equal to Fm1 plus Fb1 plus Fk1 plus Fb12. Now we can write the equation, differential equation governing this system with respect to mass M1. So our equation will be f of t equal to, equation will be m1 into d square x1 by dt square plus b1 into dx1 by dt. What are the other equations? Plus k1 into, since k1 is connected in between m1 and m2, we can write the equation as k1 into x1 minus x2. We are writing the equation with respect to mass m1. Plus b12 into d by dt of x1 minus x2. This is the equation with respect to what? With respect to free body diagram, with respect to mass m1, dynamical equation or force balance equation of the system with respect to mass m1. Now the next step is to draw the free body diagram with respect to mass m2. So the next step is draw the free body diagram with respect to mass m2. Free body diagram with respect to mass m2. So I will draw the free body diagram here. M2. As you can see, there is no direct applied forces here, but there will be opposing forces due to the combined effect. So what are the opposing forces? Opposing forces due to mass m2, that is Fm2. Opposing force due to the damper B2. Opposing force due to spring K2. And the opposing forces due to spring K1 and damper B12. So we can write the force balance equation as Fm2 plus Fb2 plus Fk2 plus Fk1 plus Fb12 equal to 0. Now I can write the equation in terms of displacement. So what will be the equation in terms of displacement? That will be m2 into d square x2 by dt square plus b2 into dx2 by dt plus k2 x2 plus k1 into, since it is associated with free body diagram of mass m2, our equation will be k1 into x2 minus x1 plus b12 into d by dt of x2 minus x1, which is equal to 0. So this will be our equation with respect to mass m2. Now we have two equations, the first equation as well as the second equation in terms of displacement x1 and x2. Now the next step is we have to replace the displacement by velocity. So what is velocity? V1 is equal to dx1 by dt and V2 is equal to dx2 by dt. So on replacing displacement by velocity, we can write the dynamic equation of the system, that is the first equation and second equation with respect to m1 and m2 as the first equation will be f of t is equal to m1 dv1 by dt plus p1 v1 plus v12 into v1 minus p2 plus k1 into integral of v1 minus v2 dt. So this is our first equation, and that means with respect to mass m1. Now we also have to write the equation, dynamic equation of the system with respect to m2 in terms of velocity, that is equation number 2. That means the above equation m2 dx2 by dt square, that equation also we have to convert in terms of velocity. So here also v2 is equal to dx2 by dt. So we can write the equation as m2 into dv2 by dt plus v2 into v2 plus k2 into integral over v2 dt plus k1 into integral over v2 minus v1 dt plus v12 into v2 minus v1, which is equal to 0. So we have got first we have to write the free body diagram with respect to m1 and m2. Now write the equation in terms of displacement, then you can convert it into velocity. So if possible you can write this equation in terms of velocity directly, but as of now or as a beginning, it is good to write the displacement equation, that is the dynamic equation in terms of displacement first, and then you can convert it into in terms of velocity. So this is the first step of doing the problem, that is to get the system equation in terms of velocity. So what is velocity here? V1 and V2 are the outputs of the system. Okay, the f of t, force is the input of the system, and V1 and V2 are the outputs. Velocity V1 and velocity V2 are the output of the system. Now what is the next step? We have to get the force voltage analogous circuit. So as we know, force voltage analogous circuit is actually what? Mesh method. And how many masses are there? M1 and M2, there are two masses, right? Since there are two masses in the force voltage analogous circuit, that is also a mesh analysis method, we will have two meshes. Since the number of masses is equal to 2, we also have two meshes in the force voltage analogous electrical circuit. As you can see in the diagram, there are two masses M1 and M2. Hence, in the force voltage analogous circuit, there will be two meshes. And corresponding to F of t, that is the applied input force, there will be a voltage source. Okay, there will be a voltage source E of t. And corresponding to velocities V1 and V2, there will be currents I1 and I2. So corresponding to mass M1, there will be a mesh, and corresponding to mass M2, there will be another mesh. And what are the elements associated with only this one, that is M1 and B1, that is connected alone, and K1 and B12, that are two elements, spring and damper, that is connected in between M1 and M2. Okay, so if you draw the analogous electrical circuit, you have to keep this in mind, because K1 and B12 are common to M1 and M2. So if you draw the analogous electrical circuit, there also the analogous elements corresponding to K1 and B12 should be common to both the mesh. So, and here also you can see M2 is one element, K2 and B2, that is only connected to M2. So, the analogous elements corresponding to this K2 and B2, that can be drawn individually. So, first we will try to draw the force voltage analogous circuit corresponding to this figure. So what are the analogous elements here? In the force voltage analogous circuit, corresponding to force F of t, in the mechanical system, here in the electrical circuit, the input is voltage E of t, and corresponding to the velocities V1 and V2, our output is currents through two meshes, that is I1 and I2. As I have already told you, corresponding to two masses M1 and M2, there will be two meshes. And the other analogous elements are corresponding to M1, there will be an inductor L1, and M2, there will be an inductor L2. B1, B2, B12, that corresponding analogous resistors are there, and instead of K1 and K2, there will be capacitor. So now we will draw the electrical analogous circuit. And in the force voltage analogy, the physical law is KVL. Okay, the physical law that we will apply is KVL. So how can we draw? First we have to draw the input voltage, that is E of t. So E of t is the applied input voltage corresponding to force F of t. Now, in the mechanical system, there is a mass M1. So what is the analogous element corresponding to mass M1? That is a inductor. So I can represent it as L1. Now, what is the other element connected to mass M1? There is a damper B1 that is only associated with mass M1, right? There is a damper B1 that is only associated with mass M1. So, corresponding to damper B1, here the analogous element is resistor R1. So, we can now draw the resistor R1. As I have told you, the connection will be mesh circuit and the connector elements will be connected in series. Now, what are the other elements that is associated with M1? that is K1, spring K1 and damper B12. But as you can see in the question, that is connected in between M1 and M2. So the corresponding analogous elements in the electrical circuit should be common to the two meshes. So we can draw corresponding to K1, corresponding to B12, there will be a resistor R12, and corresponding to K1, there will be a capacitor C1. So that is the first mesh. We can write here corresponding to B12 resistor R12 and corresponding to K2 a capacitor C1. And what is the analogous element corresponding to velocity V1? That is I1. So there will be a current I1 that passes through the mesh 1. And now we have to draw the next mesh. So as I already told you, since K1 and B12 is associated with both mass M1 and M2, are the analogous elements that are resistor R12 and capacitor C1 will be common to both mesh. So keeping this in common, we can draw the next mesh. So what are the other elements? There is an inductor, there is a mass M2, and corresponding to mass M2 we can draw an inductor L2. And what are the other elements connected to mass M2? There is a spring K2 and a damper B2. So corresponding to the damper B2, there will be a resistor. We can name it as R2, and corresponding to the spring K2, there will be a capacitor. We can denote it as C2. So I am writing C2 here. And corresponding to velocity V1, there will be a current I2 that passes or that flows in the second mesh. So this is the corresponding force voltage analogous circuit. Now we can write the dynamic equation of the system by applying KVL to the first mesh and second mesh. So when we apply KVL in the first mesh, we can write the equation as E of t equal to L1 dI1 by dt plus R1 I1 plus R12 into R12 into what? Since R12 is common to both the meshes, we can write the equation as R12 into I1 minus I2 plus 1 by C1 into integral over I1 minus I2 into dt. That is your first equation corresponding to mesh 1. And what will be your second equation? second equation will be apply KVL in the next mesh also. So the equation will be L2 into dI2 by dt plus R2 I2 plus R12 into since we are considering the second mesh, we can write the equation as R12 into I2 minus I1 plus 1 by C2 into integral over I2 dt plus 1 by C1 into integral over I2 minus I1 dt, which is equal to 0. This is your two equations corresponding to the given force voltage analogous electrical circuit. This we can write from this circuit by applying KVL in the first mesh and second mesh. Now, if you look back in the dynamic equation of the mechanical system, that is equation number 1 and 2. If you check the equation number 1 and 2, if you directly convert this equation with respect to analogous elements as f of t equal to e of t and v1 equal to I1, v2 equal to I2, and correspondingly if you directly convert using the analogous parameters, then you will get the equation. You will get the mesh equation by applying the KVL that we have already discussed. We can directly get that equation by directly substituting the analogous elements here, analogous parameters here, 4 equations 1 and 2. Then also we will get the same equations. So I will mark this as equation number 3 and this one as equation number 4. So we got the force voltage analogous circuit and corresponding equations governing the system. Now the next is to get the force current and the next step is to find the force current analogous circuit. So the number of masses in the mechanical system is 2. Hence there will be 2 nodes in the corresponding force current analogous electrical circuit. It is actually a node analysis or node method. So corresponding to the number of masses, there will be 2 nodes in the electrical circuit. So now we can write the analogous elements corresponding to force F of t, mass m1, velocities, etc. So what is the analogous element corresponding to force F of t? In the force current analogy corresponding to the input force, the analogous element is current I or I of t. And corresponding to velocity V1, the analogous element is voltage V1. Voltage at the node 1. And corresponding to velocity V2, analogous element is voltage V2. That is the voltage at node V2. Okay. Now the other parameters are corresponding to mass M1. There will be a capacitor. M2, there will be another capacitor, and corresponding to B1, there will be a resistor, but the constant is reciprocal of resistor, 1 by R1, and B2, corresponding to constant B2, and lowest limit is 1 by R2. B12 is 1 by R12. Now, with respect to spring, K1 will be 1 by, there will be inductor, and the constant is 1 by L1, and with respect to K2, the constant is 1 by L2. So, as we know, there will be two nodes, that is V1 and V2, and the input is input current I or I of t. So first we can draw two nodes, that is voltage V1, voltage at the two nodes, voltage V1 and voltage V2. Now, what is your input? Our input is a current I of t. Okay, a current I of t is our input. Now, what are the elements that is connected or that is associated with V1? There is a mass M1 and there is a damper B1. So, corresponding to mass M1 and damper B1, there will be a capacitor and a resistor. So, we can draw a capacitor and a resistor in parallel. So, as you have seen earlier, the mesh method is actually the elements are connected in series, but in node method or force current analogy, the elements, the corresponding analogous electrical circuit elements are connected in parallel. So we can draw, corresponding to the mass M1, we can draw a capacitor C1 and corresponding to V1, we can draw a resistor R1. This is C1 and this is R1. Now, what are the other elements? As you see, there is a spring K1 and a damper B12 that is connected or in between mass M1 and M2. So, since that is connected in between mass M1 and M2, these the analogous elements corresponding to spring K1 and damper B12, that are a resistor R12 and an inductor L1. You can see an inductor L1 analogous to spring K1 and a resistor R12 analogous to damper B12. That will be also common to the two nodes V1 and V2. So the elements are inductor L1 and resistor R12 will be common to the two nodes, that is V1 and V12. So we can draw the elements, two elements in parallel. Analogous to V12, there should be a resistor R12, and analogous to K1, there should be an inductor L1. So these two elements are associated with M1 and M2. Similarly, these two elements R12 and L1 are associated with, or that should be connected in between two nodes V1 and V2. Now, the remaining elements, that is mass M2 spring K2 and damper B2. They are connected only to M2. So these elements we can draw parallel with respect to node V2. So what is the element corresponding to mass M2? There should be a capacitor C2. There should be a capacitor C2, and corresponding to the damper B2 there should be a resistor. Corresponding to the spring K2 there should be an inductor. So this is the final force current analogous electrical circuit. So as you can see, corresponding to two masses there should be two nodes V1 and V2, and all the elements associated with mass should be connected in parallel. All the elements associated with M2 also connected in parallel, and the elements associated with M1 and M2 should be connected in between or draw in between V1 and V2. So this is the corresponding analogous electrical voltage, force, current, electrical analogous circuit. So we can see by applying KCL to node 1. Apply KCL to node 1, and by applying KCL to node 2 we can write the dynamic equation governing the system. So apply KCL at V1. V1 is node V1. So by applying KCL at node V1, we can write the equation as the input current I of t equal to current through the capacitor C1, that is C1 into dV1 by dt, plus inductor R1, that is resistor R1, that is 1 by R1 into V1, plus through resistor R12 and inductor L1, that is 1 by R12 into V1 minus V2, plus 1 by L1 into integral of V1 minus V2 dt. This is your equation number 5. Now similarly, apply KCL at node V2. So when you apply KCL at node V2, we can write the equation as the current through the capacitor C2, that is C2 into dV2 by dt, plus 1 by R2 V2, plus 1 by L2 integral over V2 dt, plus 1 by R12 into V2 minus V1, plus 1 by L1 into integral over V2 minus V1 into dt, which is equal to 0. This is your equation number 6. So this is the dynamical equation corresponding to the force current analogy. You can write this equation directly by applying KCL at node 1 and node 2 in this figure. Also, you can get this equation by substituting these parameters or these values in equation number 1 and 2. That is, in the dynamic equation of mechanical system, by directly substituting these values also you can write these equations. But for the exam purposes and all, you have to draw the circuit. This one is very important. So by looking or directly looking at the mechanical circuit also, you can draw this circuit. So this is the force voltage and force current analogous electrical circuit. How to find the analogous electrical circuit for a given mechanical system. So now if you get the dynamical equation by applying Laplace transform, you will be able to find the transfer function. If transfer function is asked, then only you have to find out the transfer function. Otherwise, no need to find the transfer function. So if you want to find the transfer function, you can directly find it. You can find the transfer function by applying Laplace transform in this equation. If you want to find the transfer function, you can find that transfer function by applying Laplace transform here and change it into a matrix format. Then apply Cramer's rule. For simplicity, it is always simple to apply Cramer's rule. And then you will be able to find the transfer function with respect to that is our output is voltage V1 and input voltage V1 and V2, and our input is current I. In the force current analogous circuit, your output is voltages V1 and V2. In this given system, your output is voltages V1 and V2 and the input is current I. So by applying the Laplace transform, you can find the transfer function. Note for this, for force voltage analogous circuit and for the mechanical system also. Thank you. So all of you have to do this problem in your notebook. Thank you.